In this video, I want to talk about the static variable. Static variable is a variable that don't change its value throughout the whole program. As long as a program is running, a static variable keeps its value in the RAM. So let's go ahead and check how it works. First of all, I want to make a void function. I'm going to write void. I will name this function hello. So this is a function declaration. I want to copy that and I will paste it at the bottom of the main function. So I will delete this semicolon. And here I'm going to write int num is equal to 1. I want to write printf hello number %d num. Here also I want to use \n. And here we're going to say num plus plus. So let's call this hello function within the main function. I'm going to write hello. So let's compile it and see what will happen. I'm going to write gcc -o name of file, the name of file.c. As you can see, the answer is hello number 1. Let's call this function again. I want to copy that, paste it. Let's compile. As you can see, the value of num is also 1. Hello number 1. If we call it again, it will be the same. Hello number 1, hello number 1, and hello number 1. So let's check what happened here. Here we defined a function named hello. Within this function, we created a variable, a usual variable named num, and its value is 1. And after that, we created a printf function, and we said hello number 1, and we used this num variable here. And after that, we said num plus plus. We incremented num by 1. So here, first of all, when we call this hello function, it printed hello number 1 because the value of num was 1, and it incremented the num by 1. The num became 2. And again, when we call this function, the value of num came back again to 1, and we call it again, it printed again number 1. So this was a usual variable. If we change it to a static variable, it will keep its value throughout the whole program. It will be hello number 1, hello number 2, and hello number 3. Let's check. In order to make a usual variable into a static variable, we use the keyword static. On the right is static. And if I compile it and run it, as you can see, hello number 1, hello number 2, and hello number 3. What happened here? Here we said this num is a static variable and its value is 1. We printed here hello number 1, and the value of this num is 1. And we call this function here, it will print hello number 1, as you can see here. And we said it should be incremented. The num should be incremented by 1. The value of num became 2. And again, when we call this function here again, the value of num didn't change. The value of num didn't come back to its initial value. It didn't change again to 1. It keeps its value to 2. So here we call this hello function again, and we said print this function, this printf function, and the value of num was 2 because in the first function we incremented. We incremented by 1, and here it printed hello number 2, and it incremented again by 1, and it became 3. So when we call this hello function again, it printed the hello number 3 because the value of num was 3. And it incremented the num by 1 again, it became 4. Here in the memory, the value of this num will be 4. If we call this hello function again, it will print hello number 4. Let's check. This is it, hello number 4. So this is the static variable. If we delete this static keyword, it will become a usual variable that didn't keep its value. If I compile it and run it, as you can see, the answer is hello number 1, hello number 1, hello number 1. And a usual variable is a variable that when a program or when a function ends, its value will change and come back to its initial value. And a static variable is a variable that as long as the program is running, its value will be the same in the memory. When we close this file, when we close this program, its value will come back to its initial value. So until the program is running, until the program is open, its value will be the same in the RAM. So this is the difference between the static variable and usual variable. See you next video, and bye for now.